So networking decisions. So yeah, networking, again, really important when you move into Azure, especially when you think about the security and how networking allows you to connect from on-premises or between data centers to each other. So I guess the biggest thing to think about really is how, if you're moving to the cloud, how are you going to, one, set up an environment that connects you from on-premises to the cloud, and also, how secure is that connection? How fast is that connection? There's various different things that you can think about. And of course, when you're thinking about the applications, you may need a really private link, or you may need a really strong link with fast speeds to make sure that there's no latency when accessing them. So I'll go through a few of the methods to connect on premises to Azure, and the reason why you'd put them in place or the benefits of them. First one is point to Site VPN. So this is a certificate-based authentication method that typically links single or very few clients to Azure. This could be maybe you've got an application, just one application that needs to upload data to Azure, and the rest of the environment doesn't need it. This would be a really good opportunity just to put a point to site in there and install a certificate for security purposes. If you've only got 2 or 3 members of staff that need to access Azure, this can also be a viable method as well. When we start to think about how many people are accessing, obviously if you go over 2 or 3 and you start working into the multiple people that need to access it, it may be worth setting up a site-to-site VPN. So a site-to-site VPN can be set up from your on-premises VPN appliance to a gateway in Azure. And this works off IP ranges rather than certificate-based authentication. So if you connect from an IP range that the VPN is set up with, you'll be able to communicate and ping services in Azure. This is a much more popular method we see amongst businesses that are moving to the cloud, because of the fact that if you put an IP range in there of your members of staff, so all the client machines as well as all the applications, this gives it a method of accessing from on-premises to Azure and vice versa. The only thing with this is the connections over the public internet. So, when we think about speed, so you could have 100 megabyte internet line to Azure. Obviously, this site-to-site VPN will actually take a chunk out of this line speed as well as the traffic going over the internet too. So, really popular method. Obviously, there's policies that can be put in place both on premises and in Azure to make sure that the security is maximized. But of course, this traffic is going over the public internet. So that moves us on really to the next point. So quite a lot of customers need a private connection from your data center to Azure. So if it's not possible to go over the public internet, you can actually go over the Azure backbone network by using a technology such as Azure ExpressRoute. So again, this works both with your internet service provider as well as Azure as well, with a slightly different gateway called ExpressRoute Gateway. So this is really good because it typically involves much faster speed, so you can get gigabyte connections to Azure. It's away from the public internet, so everything's private. But as you can imagine, this costs a little bit more than the site-to-site VPN, which sometimes puts customers off depending on their workloads. So if you've only got a small workload and you don't need that private connection or that really fast connection that ExpressRoute offers, obviously it might be a bit of a waste of money. So yeah, it involves much faster speeds. So for your applications, that's really good. And things, when you think about if you need to pull data from a database that's kept in Azure back to your on-premises environment, the speeds of ExpressRoute can really help with the latency you see there, rather than using a site-to-site VPN. But again, yeah, this is quite important because you will need to get in touch with a service provider that offers ExpressRoute, and that can be quite expensive, as well as the gateway method as well. So just be aware of that. It's quite a bit more expensive than site to site. So once you've made a decision on the networking option, so whether that's point to site, site to site, or ExpressRoute, it's probably time then to decide on the topology that you want to deploy in Azure. So again, this depends on what you're currently running at the moment. If you're only running a small environment, or whether you're running multiple environments at different locations in the world or in the country. So if you're only really planning on hosting a few applications and you don't require multiple dev, test, production workloads and environments, you could just deploy a single hub in Azure. You can see the image on the presentation above, which kind of replicates a hub and spoke topology, and we'll go into that in more detail just to make sense of that. But if you've only got a small environment and you don't need to isolate any workloads, you could just implement the hub, which is on the left. So the hub would contain your virtual network that you connect to from on premises. So you connect your workloads to that, or you could connect your clients to that hub, so they've got access to the resources in there. Yeah, again, no right or wrong way of doing this. If you're only a small environment, then absolutely just deploy the hub. If you are looking to, if you've got multiple offices, if you're looking to put a development, a test, a production workload in Azure, it might be worth looking at hub and spoke topology. So in this case, all of your central services, whether we're talking about firewalls, monitoring strategies, domain controllers, they can all be put in place in the hub, which is a central solution for all of your users and applications to access. And then you can then put extra spokes, which are extra virtual networks in there. So you could have one for your development arm, you could have one for your test arm, and then production. And the idea of these spokes really is to isolate them from each other. So it's important, obviously, if you've got a development and a test spoke, you don't want them interacting and conflicting with the production spoke. So we keep them isolated, so you can run your testing, your UAT, push all the code to the cloud, for example, test your application, and then obviously in the meantime your production one's still ongoing. And then when you're ready for that, you can push that to your production spoke, which again, they all communicate with the hub. They've all got communication, just not with each other. So we keep that isolation in place. With the hub and spoke as well, so you could put like a network virtual appliance in there, or a firewall. So Microsoft have got their own Azure firewall, which was released, and obviously you've still got NVAs such as Barracuda and Checkpoint, which again, really good firewalls. There's no right or wrong answer. Obviously some have more features than others, some are more expensive than others, so that's something that will need careful planning beforehand. But again, all the spokes, so your production spoke, your dev and test spoke, can all be routed through the hub as well. So we can put user-defined routes in there to make sure any traffic going to these spokes is actually routed through the firewall first. Obviously, that gives you a few benefits. One, it gives you a central place to look at all your logs. If all traffic's going through the firewall and you notice there's a leak somewhere, you can make sure that you've only got one place to view that leak. It could be that you need to set up a new rule, and instead of obviously going to network security groups and firewalls in each spoke, you can actually do it to the central place, make the change there, and it takes effect everywhere, which is really good. So it's a central place for management, which is good. And again, for these spokes to communicate with the hub, you'll need to put something in place called virtual network peering. So the idea of this is you'll have a virtual network in your dev and test, you'll have a virtual network in your production, and then a virtual network in your hub as well. So in order to connect these together, if you want isolated workloads for dev and test and production, obviously you won't want to connect dev and test and production to each other, but you'll need to put peering in place between your spokes and your hub to make sure that the communication all flows nicely. Okay, so we've spoken about virtual appliances and firewalls. Again, this is sometimes you may have a virtual appliance that you're using on premises. So if you're using a Fortinet, for example, on premises, you may want to replicate this and use Fortinet in Azure. As I say, Azure have got their own firewall that you could use as well. We see quite a lot of customers that want to keep the same, so using Fortinet on-prem, Fortinet in Azure, but we see customers as well, using new solutions such as Azure Firewall, platform as a service option again, so you don't need to patch their machines because Microsoft look after them for you. You don't have to put any updates to Azure Firewall because again Microsoft do that for you. So there's benefits to each of them that are worth looking at. So yeah, just around networking as well. So load balancing solutions, quite a key thing when we talk about applications. So we've got Azure native load balancer or application gateway. So one of the key questions really, if you're a global customer with offices in multiple locations, if you've got an application that's in East US and an application that's in North US, you want ideally your users to go to the closest one for your application so that latency is minimized. Really good thing to look at for that is Azure Front Door. Azure Front Door main purpose really is you've got two applications, and Azure Front Door is like a load balancer that will control where you route to. So if you're closer to North US, you would route to North US. If you're closer to another location, you'd route to that. So again, it just means wherever you travel to, wherever your offices are, your users are getting the best experience possible. So yeah, really good solution to look at Azure Front Door. It's gaining traction quite a lot, and we're seeing it used quite a lot as well. So if another kind of use case scenario, so if you've got multiple instances in Azure and you're looking for minimal downtime, or you might be using Azure as a disaster recovery solution, you can use a technology called Azure Traffic Manager. So Traffic Manager can have multiple endpoints configured to look at your on-premises environment and Azure, and then you can put rules in place and kind of health probes in place to make sure that traffic is always routed to healthy endpoints. So we see this quite a lot at the moment with two firewalls, two different environments. So if you've got a VPN appliance on premises but you're using Azure as a DR strategy, you've got a firewall on premises and one in Azure, Traffic Manager can be set up so it continually probes both the on-premises device and the Azure device, and then you can put priorities in place. So if, for example, the Traffic Manager sends a request to the on-premises as part of a health request and it finds that it's down, you could set that after 3 failed attempts, it's pretty obvious you've got a failure on premises, and Traffic Manager will actually start routing your clients if set to the Azure firewall. So this takes a piece of the puzzle out of the mix when you have to invoke your DR solution. Instead of having to reconnect everyone's VPN profiles, you could just point them to the Traffic Manager solution. So then Traffic Manager will handle where your users connect to. So if on premises it goes down, touch wood it won't, then Traffic Manager will start to route everyone to Azure and service will be resumed as quick as possible. And again, this isn't just for on-premises and Azure. It can be used for Azure native only. So, if you've got 2 different locations, you could probe the first location and then move over to the second in a different data center if that was to go down. And again, I keep reiterating it again. After all the decisions have been made, make use of Azure policy so that we're locking the decisions down. Put that governance in place to make sure that the solution you choose, you stick to, and then that can always be changed at a later date. And that way we're maximizing the governance and the compliance of your environment as well.